Imagine a world that wants to kill you instantly. No fresh air, no blue sky, just a toxic, suffocating alien wasteland. The oceans were purple, the air was thick with methane, and if you tried to breathe, your lungs would basically melt. But for the early inhabitants of Earth, primitive microbes, this was paradise. They loved the heat and the sulfur. Oxygen? They hated it. To these creatures, oxygen was a corrosive, reactive, and highly dangerous explosive. It sounds weird to us, but back then, oxygen was essentially the cyanide of the planet. Until someone broke the rules. Enter the cyanobacteria. These tiny green rebels decided to stop scavenging for food and do something radical. They invented photosynthesis. They figured out how to use sunlight, water, and CO2 to make their own energy. It was the most efficient energy source ever. But there was one tiny, invisible problem: the exhaust gas. Since the sun was free and the water was everywhere, the cyanobacteria multiplied. Fast. Everywhere. For millions of years, the Earth tried to soak up this new oxygen. It rusted the iron in the rocks and filled the seas. Earth was literally rusting. But eventually, the sinks were full. The oxygen had nowhere left to go but up into the atmosphere, and that's when the Great Oxygenation Event truly began. It wasn't a breath of fresh air, it was a global chemical attack. For the old, oxygen-hating life forms, this was a disaster. They were being burned alive by the very air they lived in. Nearly every single species on Earth was wiped out. But wait, it gets even worse. Because oxygen didn't just kill life, it broke the world's thermostat. And Earth was about to turn into a giant frozen popsicle. The Great Oxygenation Event. A story about how a tiny green miracle became a global disaster. Before the crisis, Earth had a cozy secret: a thick atmosphere of methane. It acted like a giant warm blanket. This methane was 25 times more effective at trapping heat than CO2. It kept our young planet from freezing solid. But as our cyanobacteria friends kept pumping out oxygen, they were unknowingly launching a chemical war. When oxygen meets methane, they react. The methane is destroyed, replaced by carbon dioxide and water. CO2 is okay at keeping heat in, but compared to methane, it's like replacing a winter duvet with a thin, wet paper towel. The heat escaped into space. Temperatures crashed. The planet's surface began to freeze, starting at the poles. And here's the kicker: ice is white. It reflects sunlight back into space instead of absorbing it. This is the albedo effect. This created a feedback loop of doom. More ice meant more reflected heat, which meant more cold, which meant even more ice. In a geological blink of an eye, the ice sheets met at the equator. The Huronian glaciation had begun. Earth stayed like this for up to 300 million years. To put that in perspective, that's longer than the entire age of dinosaurs. Under kilometers of ice, in the dark, cold oceans, life was hanging on by a thread. But it wasn't dead yet. While the surface was a freezer, the Earth's core was still a furnace. Volcanoes were building up pressure beneath the ice. Volcanoes don't just release heat, they release CO2. And since there were no oceans to absorb it, the gas just built up and up until the greenhouse effect returned with a vengeance. The snowball was about to melt. Fast. The ice didn't just melt, it vanished. Earth went from a freezer to a sauna in a geological heartbeat. The oceans were now saturated with oxygen. The chemical makeup of the planet had been changed forever. For the remaining life forms, the choice was simple: adapt to this toxic new world or go the way of the dodo. And some organisms did something brilliant. They figured out that oxygen, while dangerous, was actually a fantastic fuel. By using oxygen to burn nutrients, life could extract significantly more energy from every single meal. This is aerobic respiration. It was the evolutionary equivalent of going from a bicycle to a rocket ship. With all this extra power, life was no longer limited to being a microscopic, lazy blob. It could start to dream big. But the most important moment in this story happened when one cell decided to eat another cell. And things got weird. Instead of digesting the little guy, the big cell realized, hey, if I keep you around, you can make energy for me. This was the birth of the eukaryote, a partnership that led to every plant, animal, and human you see today. Without that tiny green poison breather moving in, life would have stayed simple. No trees, no flowers, no us. Everything you are is thanks to a chemical disaster that happened 2.4 billion years ago. You are built on the ruins of a genocide. So maybe we should thank the cyanobacteria. They were the world's first polluters, but they were also our first engineers. Today, our atmosphere is stable. 21% oxygen, just right for us. But history shows that balance is fragile. The Great Oxygenation Event was the first mass extinction, but it wouldn't be the last. Next time, the danger wouldn't come from a bacteria, but oxygen did more than just fuel our cells. It began to build something high above our heads that would change history. For billions of years, the sun's ultraviolet rays hit the Earth's surface with full, deadly force. When UV light hits an oxygen molecule, it's so energetic that it literally rips the molecule in half. These lonely atoms then find other O2 molecules to cling to, creating O3, better known as ozone. Slowly, a layer of this gas wrapped around the world, acting like a giant global pair of sunglasses. With the ozone shield up, life finally had its get out of the ocean free card. The land was open for business. For millions of years, giant forests conquered the continents. They were the ultimate oxygen factories. Oxygen levels didn't just stay stable, they skyrocketed, reaching a staggering 35%. Compare that to our 21 today. In this supercharged air, insects, who don't have lungs like us, could grow to nightmare proportions. Imagine a centipede as long as a family car. This was Arthropleura, the largest land invertebrate to ever live. But there was a terrifying downside. Oxygen is a fuel for fire, and 35% oxygen meant the world was essentially soaked in gasoline. During this time, a single lightning strike could trigger a forest fire that was impossible to put out. Under these conditions, even wet wood would burn like dry paper. Fires were more frequent, hotter, and more destructive than anything we see today. Nature was stuck in a cycle of boom and bust. Total growth followed by total incineration. This buried carbon didn't just lower oxygen levels, it turned into the coal we use today. We are literally burning the 300-million-year-old ghost of these forests. It's a strange irony. The event that nearly froze the world also created the fuel that is now heating it back up. The history of oxygen is a history of extremes. Too little, and you freeze. Too much, and you burn. But without these wild swings of fate, we wouldn't be here to tell the story. Next time, we'll see where we go from here. How do we know all this isn't just a bedtime story? How can we see a disaster that happened billions of years before the first dinosaur? Behold, banded iron formations. These beautiful red stripes are the literal scars of the Great Oxygenation Event. When the first oxygen hit the iron-rich purple oceans, it turned the iron into rust, which fell to the floor in massive waves. For millions of years, it snowed rust. These layers are so massive, they provide almost all the iron we use to build our cities today. Your car, your kitchen knife, the Eiffel Tower, They are all essentially the leftovers of an ancient microbial war. But what if history repeated itself? What if we doubled the oxygen in our atmosphere right now? First, everything made of iron would start to rot. Your car would literally crumble into a pile of orange dust in weeks. And fires? They'd be unstoppable. A simple toaster would become a flamethrower, and forest fires would be permanent. But you'd feel like a god. With all that extra fuel, your body would have incredible energy and focus. This is why scientists look for oxygen on other planets. It's a biosignature, a sign that something is alive and messy. The GOE reminds us that even the smallest, most insignificant creature can rewrite the rules of the entire universe. Oxygen isn't just a gas, it's a legacy of survival, a byproduct of death, and the very thing that connects us to the first life forms. We've seen the evidence, we've seen the future. But how does this story end? Join us for the final chapters. We take every breath for granted. We think of oxygen as life's greatest gift. But for the universe, it might be life's greatest trap. For 2 billion years, Earth was a chemical crime scene. Oxygen was the poison, and life was the victim. This brings us to a terrifying theory, the Great Filter. A hurdle so difficult that most civilizations never make it across. Maybe the universe is full of planets where life just stays simple. Purple blobs enjoying their methane, never evolving. Because to get complex, you need energy. And oxygen is the only fuel powerful enough. But it's also a fuel that kills you. Earth won the cosmic lottery. We didn't just survive the poison, we domesticated it. We turned the apocalypse into an engine. Somewhere out there are probably millions of Snowball Earths that never melted. Millions of rusted worlds where life failed. You are the result of 2.4 billion years of luck, resilience, and sheer biological stubbornness. But being lucky isn't enough. The GOE taught us that life doesn't just survive change, it drives it. We are a planet-shaping force. Today, we are the new cyanobacteria. We are changing the atmosphere faster than at any time since the Great Oxygenation Event. The question is, will we be as resilient as those tiny green microbes? Or will we become another rusted layer in the rocks? But history shows that life is incredibly good at turning disasters into opportunities. We have the knowledge they didn't have, so let's not waste our breath. We have a planet to protect and a legacy to uphold. After all, it took 2 billion years to get here. The next time you take a deep breath, remember, you're breathing in the history of a revolution. A revolution that never ended. That's the end of our journey through the oxygen apocalypse. But don't go just yet. The credits and the end card are coming up. Creating these animations takes thousands of hours and millions of O2 molecules. This video was made possible by our supporters.